Well, interesting thing. Suppose we have two long wires. So we have a long wire that has current flowing it that way, and another long wire current flowing that way, and they're separated by some distance d. And so I want to know, because I1 creates a magnetic field, and we know that magnetic fields exert a force on current. What's the direction of magnitude of the force on these wires? Okay, so due to I1 has a magnetic field using the right-hand rule. It's coming out of the board here and into there. I2 has a magnetic field that's out above it and in below it. Okay, and right-hand rule, we know that the magnetic field here, okay, is mu naught I over 2 pi r, okay. We also know that the force on a wire, so now there's a force on this wire right here. So we know the force on a wire is equal to I L cross B. Okay, so that means that L cross B, there's going to be a force this way on that wire. Well, up here, then it's a force that way on that wire. Okay, so that means these two wires are actually attracted to each other. Okay, so how much are they attracted to each other? Well, okay. So we got I1, we got I2. Okay, so let's just look here. Here's the magnetic field here due to wire 1. We'll call that B1. Okay, so the force on wire 2 is going to be equal to I2 times L times B2. Okay, and so that's going to be I2 times L times mu naught I1, or sorry, B1 rather, right there. Mu naught I1 over 2 pi d, because I said that separation was d. And so the force here is going to be upwards. So this is going to be upwards. So if I say that way is going to be the j direction, okay, then the force here is going to be I2 mu naught I2 I1 L over 2 pi d j. Well, what about the other wire? Okay, so for the other wire, then the magnetic field here, we'll call that B2. So B2, we got the force on wire 1 is going to be I1 times L times B2. So that's going to be equal to I1 times L times mu naught I2 over 2 pi d. So that force is going to be equal to mu naught times I1, I2, L over 2 pi d, except it's going to be going that way, so that's negative j. What do you notice about those two forces? They're equal and they're opposite. Well, of course they are. That's Newton's third law. They have to be that way. Normally what we would do is we would say the force F over L, rather than just the force itself, is going to be mu naught I1, I2 over 2 pi d. So this is the force per length there. So there we have an expression. There's the force per length on parallel wires. Now, next question. What if they were in opposite directions? What would happen? So if the wires are parallel, they're attracted. What if they're opposite? Well, right-hand rule, due to the upper wire, there's going to be the upper wire, creates a magnetic field like that, which right-hand rule for the other wire is a force that way. The lower wire creates a magnetic field like that, okay, which for the upper wire is a force that way, okay. So that means if the wires are in opposite directions, or the currents are in opposite directions rather, then the forces repel. Okay. So parallel wires are attracted together if the currents are running in the same direction, and if the currents run in the opposite direction, they're going to repel each other.